So here's us. We did our daily puzzle, which was actually a riddle. And what I want to do next is I want to observe this data set with you and ask you a few questions. So I'm going to have you guys respond to me in the chat, and preferably respond to everybody, not me privately, because we're just going to kind of make sure that we all understand a few concepts that we can pull from this data set. So before we even start, I made a mistake on your assignment. I made a mistake. So this graph you're looking at here is actually not quite the same as the graph in your assignment. Can anybody tell the difference? What is the difference between the graph in your assignment
The numbers on the left
and
are
this graph?
way larger.
The two animals are switched, yes. Okay, so that is the key thing to notice, is that the two animals are switched. In your assignment, the lynx population was this like taller blue curve, and the hares were the shorter red curve. Does that make sense for the lynx population to be bigger than the hare population? Can somebody explain to me why that actually matters?
Wouldn't they run out of food? Because one lynx eating one hare, eventually they'd have to run out of food unless they were sharing.
What do we know about the relationship between the lynx and the hares? What kind of relationship is it? Yeah, it's a predator-prey relationship. Now, if I have like maximum, I don't know what, 40,000 prey, can I have more predators than that? No, you're right, Elias. So they'd run out of food. So in general, we're going to expect that our prey population needs to be larger than our predator population. And hopefully that makes some sense. It's going to take more than one rabbit to keep a lynx alive. Hopefully that's kind of intuitive. So it's not a huge deal. You could still think about these ideas, but can somebody, here's my first question to you. Can somebody explain or throw out in the chat, hopefully multiple people, what is one reason that the hare population could have gone up here from like the beginning of the graph to like 1912? What are some reasons the hare population could have gone up? Less hunting from the lynx. So maybe if there's this lower lynx population here, we can see that the lynx population is lower on the graph than it is over here. So it would make sense that the hare population can go up if there's not as much hunting going on. What are some other conditions in general that you might expect would let the hare population grow during that time? Yeah, Charles, so more food, which could mean more babies. So we've got two things in there. We've got plenty of resources and we've got a high birth rate. Okay. Now, what are some things, if we look at this red line, that would let the lynx population grow here from beginning of the graph to like 1914? Right, same thing. So for the hares, we were probably talking about the amount of plants that there were available for food. But for the lynx, we're talking about the number of hares. So we see the number of hares goes up, and then there's a little bit of a lag, but the lynx population follows, right? So as their food source increases, so do they a little bit after. Yep. Now, someone going back in the chat, someone mentioned that a factor that is going to influence the hare population is their camouflage. So one thing that people who studied the tundra talked about in their biome projects was, so we've got climate change going on. What do we know happens to snow as a result of climate change? It melts. Yep. So if you've got this snowshoe hare who has a white coat, how much camouflage does it have when it's cold like it's supposed to be in the tundra. It's got pretty good camouflage. But once the snow melts, maybe as a result of global warming, maybe something else, but if the snow is gone, its camouflage is gone. So maybe we can see the result of that on a graph. But right here, we're seeing the predator-prey interaction. Okay, so now everybody in the chat, estimate for me, what would you say is the carrying capacity of our lynx population? If you had to throw out a number, and please nobody tell me like 40 lynxes. Remember, we're talking in thousands here. Ooh, I like this. I've got people saying things from, I've got 41,000, 47,000, 49,000, 51,000, 47,000, 45,000. I love it. Okay, so notice all of those numbers, 41,000, 48,000 is another one I just got, 45, 47. Are any of those the highest population you see on the graph? No, they're not, right? Because the highest population you see on the graph is probably above the carrying capacity. Probably at that point, we're running out of resources and the population starts to fall. So we're not going to pick the absolute highest, but we're going to pick something that's a little under that point. And I've got a lot of people talking about like mid to high 40s. So that would be a reasonable guess. Somewhere in here is probably a good carrying capacity estimate for the lynx. So what I want to just outline for you is this quiz you're about to take. It has basically these exact types of questions. It asks you to think about limiting factors for a population. It asks you to estimate carrying capacity. It asks you to consider like what would happen if a new group of predators came into the area. It's basic things just like what you found on this predator-prey graph analysis. So I'm going to awkwardly stare at the chat for exactly 1 minute now while you guys write the questions that you have about those topics. If you were asked to look at a graph very similar to this and point out things like limiting factors, carrying capacities, reasons for changes in the population, what type of relationship a graph is representing, what questions do you have? Now, privately in the chat, I want you to all either type easy, so-so, or hard to tell me, how was this activity for you? Was it easy, so-so, or hard? I love this. My answers are streaming in. Okay. Okay, so I've got a good question. A couple of people aren't quite sure how to find the carrying capacity. So I am going to explain it right now one more time, but if you have a good way of explaining it that might be helpful to this person, will you just type a general how to in the chat to everyone? How to find the carrying capacity. Help your peers. I'm going to try to explain it, but if you could summarize it generally, type it in the chat, help them out. So if it's me, I'm going to go find on this graph, let's do the hares now. I'm going to find what is the biggest this population ever gets. And I know that it's going to be a little bit below that. So it's not going to be the absolute peak. So for my hares, what do you guys think is the absolute max that population ever gets on this graph? Estimate. It's the absolute max. Yeah, like probably 78,000, 75, a little bit above 75, maybe 80. So this point is the max. So that's not the carrying capacity. That's probably a little bit above the carrying capacity. So I would probably be guessing something that's a little bit below the absolute max. On another graph, it might be easier to tell, but it's something that's a little bit below the absolute max. So here, I would guess, since this line is at 75,000, I would guess, maybe it's like 70,000. Does anybody else have a better way of thinking about that? So it can't be the absolute max because at that point we see that the population starts to fall. So we probably overshot the carrying capacity a little bit, but it's very close to the top, the biggest population you see. What other questions do we have? Or are we ready for this little mini quiz? Okay, if you are ready, here's the plan. The quiz is linked through my Canvas homepage as always. The passcode is go-outside, which is what I hope you're gonna do this weekend. Wear a coat, it's gonna be cold. Go outside, this dog really wants to. Isn't that cute? Okay, so in our Canvas page, you will find on Friday this link to the mini graphing quiz. You'll click it. You'll do those, I think it's 8 questions. Most of them are multiple choice or something like that. And you will take off and have a great weekend and go outside like my little dog here. I'm gonna stay on here. You're gonna stay on here until you're done. And then that way you can ask me any questions. But you guys are welcome to do that.